Hello, my students in grade 9. This is a mathematics lecture 7. The title of our lecture is Thales Theorem. And this is a theorem that we apply in triangles. This is a very important theorem as the theorems that we learned together last year, the Pythagoras theorem, the midpoint theorem. We directly apply this theorem if we can. So what are the objectives of our lesson? Objective number 1, identify and apply Thales theorem. We will know where can we apply Thales theorem and how do we apply it. Number 2, every theorem has a converse. We use the converse of Thales theorem to prove two parallel lines. Number 3, prove that a triangle is the reduction or enlargement of another triangle. Let us start. In a triangle ABC, so we have these three figures in front of us. We have in each figure triangle ABC. So this is triangle ABC, or this is triangle ABC, or here we have a triangle ABC. Let M be a point of line AB. So I put M on is a point on line AB, and N is a point of line AC. So I have taken two sides of this triangle, and in this triangle, I placed 2 points M and N on the two sides. But how did I place them? I placed A, B, and M, A, B, and M, A, C, and N in the same order. So M is between AB, so N should be between AC. And they are far away from each other's the same distance. So I have A, M, and B. Here I have A, N, and C. So I can place M and N between them. If I placed M outside AB, I should place N outside AC. If I placed M outside AB from above the figure, I should place N on AC also above the figure. So this is what we mean in the same order. Between, outside from below, outside from above. After placing M and N, I join MN with a line. So I have now MN parallel to BC. Also here, MN is parallel to BC. MN is parallel to BC. I say, since MN and BC are parallel, so we can use Thales theorem. So to be able to apply Thales theorem, I should have two parallel lines. This is the condition to apply Thales theorem. We only apply it if we have two parallel lines. How do we apply it? Look at the parallel lines. Line MN and line BC are parallel. Which vertex of the triangle is facing the two parallel lines or is opposite to the two parallel lines? It's vertex A. A is facing MN and A is facing BC. So I take the main vertex A. How do we apply Thales theorem? So always to start applying Thales theorem, I should ask about the vertex opposite to the two parallel lines. It's A. So I start writing ratios. I write AM over AB is equal to AN over AC is equal to MN over BC. Again, look carefully how I am writing the ratios. I write AM over AB is equal to AN over AC is equal to MN over BC. Or I can say AM over AB is equal to AN over AC is equal to BC over MN. Or I can write it AM over AB is equal to AN over AC. So always when writing the ratio, I start from A. Then I write the parallel line MN over the parallel line BC. So this is how we apply Thales theorem when having two parallel lines in a triangle. Let's take an example. We have a triangle ABC. We placed M on AB between them, so I place N on AC between them. So we get MN is parallel to BC. I have the measure of AM, I have the measure of AB, I have the measure of AN, I should calculate the measure of AC. Why do I use Thales theorem? I use Thales theorem to calculate a missing measure in a triangle. So I say, since MN and BC are parallel, use Thales theorem. Let's start applying. Which vertex is opposite to the parallel lines? It's vertex A. So I start writing my ratios. AM over AB is equal to AN over AC is equal to MN over BC. Now I should choose between these three ratios. I only choose two ratios to calculate AC. I say AC, where is AC? In which ratio? It's in ratio 2. So I need to use ratio 2. Between the other two ratios, which measures I am given? I'm given AM and I'm given AB. So I take the first two ratios together. I take AM over AB is equal to AN over AC. Now I replace the given measures. Then I get a fractional equation. I do the cross multiplication. 4AC is equal to 72. So AC is equal to 72 over 4. So I got the measure of AC, which is 18 centimeter. In this way, we apply Thales theorem. We have derivatives from Thales theorem. We can use other ratios. This means, what are the other ratios? We can use AM over MB is equal to AN over NC, but I cannot write equal MN over BC. Never. We can also use BM over BA is equal to CN over CA. These are derivatives you can use. Now, as another application, in the following triangle, we have EF is parallel to KL, and we have the measure of MK, we have the measure of LF, we have the measure of KE. We should calculate the measure of ML. So I have MK and I have KE. But I need the measure of ME. So how do I get ME? It is MK plus KE. So I add 2 plus 4, it is equal to 6. Now I say, in triangle MEF, since KL is parallel to EF, apply Thales theorem. Which vertex is opposite to the two parallel lines? It's vertex M. So I write the ratios. MK over ME is equal to ML over MF is equal to KL over EF. Now I choose between the ratios. So these are the ratios. I have MK, I calculated ME, I have ML, I should calculate ML and I have MF. So I take the first two ratios, I do the cross multiplication and I get the measure of ML. The converse of Thales theorem. First, why do we use the converse of Thales? We can apply Thales if we have parallel lines. We use the converse of Thales to prove that two lines in a triangle are parallel. So the converse of Thales is used to prove two parallel lines. Suppose I have a triangle ABC. I have M is a point on AB and I have N is a point on AC. I'm given AM, I'm given AB, I'm given AN, and I'm given AC. I should prove that MN is parallel to BC. So I say, in triangle ABC, I get the ratio AM over AB. I calculate it and I get a result. Then I calculate, sorry, AN over AC and I get a ratio. So I get the first two ratio AM is equal to AB. If it's equal to AN over AC, then the two lines MN and BC are parallel. Let's do an application. Given a triangle ABC, we are given AB is equal to 6 centimeter, AC is equal to 8 centimeter, AM is equal to 3, and AN is equal to 4. Show that MN is parallel to BC. So I say I should calculate AM over AB. I first calculate the first ratio. So AM over AB, so I write 3 over 6, and I reduce my ratio, so I get the answer 1 over 2. Then I calculate the second ratio, AN over AC. So I write 4 over 8, and I reduce my fraction over 4, so I get 1 over 2. So I calculated AM over AB, it's 1 over 2, which is 0.5. AN over AC, it's also 1 over 2, 0.5. Then I say, since these two ratios are equal, so applying or using the converse of Thales theorem, then line MN is parallel to line BC. Now, enlargement and reduction of a figure. What do we mean by enlargement? Enlargement, we made something bigger. Reduction means we made something smaller. So let us start with enlarging a figure. Suppose I have a triangle ABC. This is a triangle. Now, what did I do? I placed a point O outside the triangle ABC. Then I have taken a point A prime such that OA prime is equal to OOA, to OA 2 times. Then I've taken a point B prime such that OB prime equal to OB. Then I have taken a point C prime such that OC prime is equal to OC. To OC. So I've made OA as OA prime, I've made OB, I've enlarged it to OB prime, I have enlarged OB to OC prime. Now I got a triangle A prime, B prime, C prime. I want you to look at the black triangle ABC and the red triangle A prime, B prime, C prime. As you can see, this was small, now it became bigger. So here I am enlarging, I'm making my black triangle a bigger triangle, which is the red triangle. So what do we say? Now we say in triangle O, A prime, B prime, we have AB is parallel to A prime, B prime. So we have these two lines are parallel to each other. Then applying Thales theorem, we have OA prime over OA is equal, because I'm enlarging, so I write the bigger one over the smaller one. So OA prime over OA equal OB prime over OB equal to A prime B prime over AB. So after I get the ratios, I calculate them. So I say triangle A prime, B prime, C prime is the enlargement of triangle ABC by a scale factor. Suppose I here enlarged times 2, it is 2, and the center is O. Reducing a figure, making a figure smaller. Here I have the basic triangle is ABC. After putting 2 points M and N, M is on AB and AM is equal to 1 over 3 AB, N is on AC and AN equal 1 over 3 AC. So here I've made AC smaller and here I have made AB smaller. So I got a triangle AMN. If you look at AMN, it is smaller than ABC. So here I have AM over AB is equal to AN over AC is equal to MN over BC. I calculate the ratios. Then I say triangle AMN is the reduction of triangle ABC of center A. Always I should specify the center of reduction. It is the vertex opposite to the parallel lines, and of scale factor, I have make them smaller by 1 over 3. Always in reduction, we write the smaller measure over the bigger measure. In enlargement, I write the bigger over the smaller. So this was our lesson, the Thales theorem lesson. Please, again, as I say, watch this video well. And after you watch it, if you have any question, please contact me. Thank you.